Hello, everybody. Good morning, good evening, good afternoon, depending on when you're watching this. I hope you're having a great time at AU so far. And today we're going to talk about our lessons learned in 3 years using Forge and the cloud. So cloud applications are changing the way that we communicate, the way that we work, and even the way that we live, especially with all the events that took place last year. This very presentation on this very event is a proof of that. AU was always a person-to-person event. Last year, I was in Vegas presenting to my audience, and now I'm here on my home office in Australia, and you guys are all over the world watching this. So welcome and nice to have you virtually here. My name is Thiago Almeida, and my career is a kind of a mix. I first graduated as a product designer and a few years later moved to civil engineering. With a lot of different trainings on software development in between, I'm currently working as CTO on Shedmate, a startup that uses Forge to help anyone to design residential and commercial sheds even from their mobile devices. I'm passionate about engineering, mathematics, and have been an Autodesk ADN user for a quite long time now. And here's my coworker, Raphael.
Hello everyone, my name is Raphael Rodrigues and I have a bachelor degree in information systems with a full stack background. I already worked with desktop, web, and mobile development, and now I use this knowledge gathered to develop Revit plugins and Forge-based applications. I'm super passionate about technology, I love it, and I'm always trying new things out.
Thanks, Raphael. And before we begin, let's set some expectations. So today's session is all about our experience using Forge, and the apps that we have built are mainly focused on the AEC industry. So you see things here that you might apply to other industries, but the main focus of today's presentation will be about Forge for construction and their APIs. Okay, so, and the other thing is there will be a lot of talking in this presentation. So if you're more like a hands-on developer and you prefer to get your hands dirty, definitely check out this other presentation. It's a lab that I'm doing with my coworker, Eduardo. Okay, with that out of the way, in today's session, we are going to discuss how was the process of us changing from desktop to the cloud. So the big word here is collaboration, how we can produce AEC solutions with collaboration in mind. Also, changing to the cloud is a big move by itself, but it doesn't mean that we need to throw everything away that we have been doing for years and just start from scratch. So we're going to talk about that too. The other relevant thing is how we can leverage Autodesk Forge APIs, and to do all the heavy lifting for us. How we can use all this to deliver data-rich applications to our customers with less effort. And since our team was mainly focused on desktop development before, and Forge was the thing that influenciated us the most to make that jump, we're going to share some of the lessons learned on that process with you guys by quickly going through the different Forge APIs that we use the most and discuss some of the issues and some of the hiccups that we have along the way. And these things here are sometimes not found directly on documentation or online, so hopefully that will help you along the way as well. And since we're talking about that, we need to know when is the time to start that journey. I would say that the time is right now, but as we all know, there will be different situations and different things for different people, different applications. So let's jump right in on what are the advantages and what there are the disadvantages of using the cloud. And then you can hopefully come up with the answer for that question yourself. So cloud applications, they have been around for a while now, and most of our users, they already know how to use them. They already know the ins and outs of logging into a website or a web browser, and that also empowers our users to consume our applications. So it's an easy environment for them. We can take advantage of their existing phones and tablets, existing hardware. They have that and carry that on their pockets each and every day. So just to use our applications, they just need to pull up their phones and start browsing, as opposed to buying expensive professional hardware, having installations, deployments, and things like that, right? So that also leads to better data interactions as well. So no more that, can you send me that email and then I'll look that after, or can you copy that project to me or on my flash drive and I'll get back to you tomorrow or something. Data sets are now available globally and they can be accessed from anywhere basically. That prevents something that is haunting us for years now on the AEC industry, the so-called data silos. So in this presentation, we ourselves, we're on, like I am on Australia and Raphael is in Brazil, and we are doing this presentation together here, and we're collaborating together in real time. We are using PowerPoint and OneDrive to send all that information back and forth. So we have all these pre-built infrastructures from companies like Microsoft, Amazon, and Google, and they provide infrastructure that can be accessed on demand. That decreases the need of robust on-premises hardware and maintenances. That shortens also the terms of development and the cycles, and everything helps us to deploy better solutions and prototype in less time. Effort and costs are also mitigated, and all that turns out to be fast turnover to our businesses. And this is like a controlled environment too. Most of the important processing can be offhanded to a virtual machine in the cloud, and we can control exactly what is happening there, the amount of memory, the processing power, and we can get much more information of bugs and issues as they arise, as opposed of trying to see what happens on someone else's machines and stuff like that. And these environments are very, very flexible and modular. So you can scale up really quickly. You can go from 20 users to 20,000 users, and you also allow to integrate that all with different services, providing a lot of business opportunity and growth. And with all of that, you can also establish security connections to databases. You can store sensitive data in the cloud with a lot of the security layer already pre-built for you. So you can take advantages of all this years and years of research and development and investment from these big players like Microsoft and Amazon to really leverage security on your application. Well, of course, you need to go through some steps, and you need to provide your own layer of security on top of that. But it's much less effort if you're already using some of their services.
Okay, what about the disadvantages of cloud applications then? You saw that security was listed on the advantages list, and it is listed here as well. And that's because security can either be a huge quality of your application, or it can be your worst nightmare. And this depends on how the security is approached. Since this is a huge concern, because we have examples of big scandals throughout the years about hacking invasions, data leak, gathering, and usage of information. This is one of the most important considerations about the cloud, and it's always something that is immediately brought to the table when cloud solutions are proposed. With that concern in mind, governments around the world have been increasing regulations around data retention and usage. These regulations can be quite complex, and they are oftentimes different from country to country, making it even harder to comply with. Another thing is that the change can be extremely overwhelming, especially for a team that is used to desktop environment. It was for us. It requires a lot of getting used to the new technology and even on the philosophy of your company, how you provide solutions, how you solve problems of your customers and stuff like that. What about the investments? This change requires investment to port your existing applications. Even though we try to build modular pieces of code, clean architecture, and things like that, the reality is that most of our existing business logic is tied to specific platforms. And that happened even with Autodesk itself when they were porting Revit to the cloud. It was a huge time and money investment. Latency and internet speeds are also something that we need to be aware of. Our projects need to create and consume tons of data to be effective. You would be surprised on how much gets produced by simply clicking two points to create a wall. This data adds up quickly, and sending it over the wire, it's already a challenge. Not to mention processing in a remote environment. But actually, the infrastructure of internet connection is improving really fast around the world. So this is not much of a disadvantage today. It's more of a concern. It's more of a thing that you need to keep in mind when providing solutions to the cloud. Another thing is that we need a multidisciplinary team. We know that we're going to need more specialists in security, databases, load balancing, and all of this. But something that particularly gets overlooked is the actual interaction between these professionals. A software architect plays very different than a construction architect in a team developing a software for AEC. A facade is a software design pattern for one and exterior faces of the building for the other. What about the development experience of Forge? The supporting team behind Forge is amazing. Not only they are excellent software engineers themselves, they are as passionate about these things as we are. So they are always open and willing to help you succeed. What about the community? The community is beginning to grow, and you can already find lots of resolution for common problems online. And this is essential for any tech to grow properly, right? What about the documentation? This is interesting. Every API contains an introduction text with an overview of important topics and terms, making it easier to know more about the features and possibilities. Even if you didn't use this API before, it makes it really easier to figure out and know what the API is all about. Every endpoint contains all information you need to access it, like the type of authorization token, for instance. They also contain examples for both the request you send and the response you get back. What about training resources? This is super helpful. All APIs contain developer guides and step-by-step tutorials provided by Autodesk to cover a range of different scenarios and explaining how to use the APIs. Not only that, Autodesk have a website called Learn Forge that shows the step-by-step to create a Forge application, consuming multiple APIs in a workflow that makes sense. And to finish this off, there's no better way to see the power of a tool than actually testing it out. And Forge have an extensive library of working examples for you to access and play around. You can just open an example and play around with the features, change the camera angle, stuff like that. Now, we're going to talk about the Forge APIs, explaining their capabilities to help you understand which one to use on your solutions, and giving some tips and tricks that we learn along the way. All right, we're going to start with the authentication API. This one is the very first API to be used. Its purpose is to provide access to all other Forge APIs, and this access can be delivered in different ways with different levels of permission. The token can either be of a two-legged or three-legged type. The two-legged token communication will happen between your web application and the Forge servers. The level of permission is more generic, and this token can be used on features that are not user-specific, like listing projects and opening models on the viewer. The three-leg token, in the other hand, it's called this way because the user is actually part of the communication and have to grant permission to the application. This type of token allows the application to get user-specific information, like project issues. The authentication API follows the OAuth 2 standards, and it can be a little bit tricky for beginners. And thinking about that, Thiago actually recorded a demo video showing the step-by-steps of creating the Forge app and doing the initial configuration, exploring the endpoints, and configuring the requests. So if you're interested in a more step-by-step approach, please check the class materials and you can watch the video. The next API we're going to talk about is the Data Management API. This one allows users to access and control data from all Autodesk's cloud products, BIM 360 Team, Fusion Team, BIM 360 Docs, and if your company does not use those services, you could use the Object Storage service that was created exclusively to Forge. Having a centralized and consistent way of accessing data is the true power of this API. No more data will get lost on someone's hard drive. This API will really unlock the potential of a cloud-based application and will allow all of the information to be accessed when needed by the user that needs it. All right. What about the object storage service? This is a really interesting one. Companies can create storage buckets to receive files and organize them however the business model needs them to be. And there's one thing to notice here though, is that every file stored on the OSS follow a retention policy, which is basically the period that they will be stored. You can have transient files that last for 24 hours. You can have temporary files that last for 30 days, or even persistent files that will last until they are deleted. Model Derivative API. The model derivative API is used to perform file translations, extract thumbnails, and extract geometry into other files or even extract metadata about the model, like parts properties, for instance. The translation feature is super powerful. There are over 60 different supported file formats that can be converted to derivatives, like .svf, which is the format used to display models in the viewer. If the company uses BIM 360 though, they don't need to worry about file translations. This is all handled by BIM 360 itself. The thumbnails of a model can be generated using the API as well, and they will be available in three different options of sizes: 100 by 100, 200 by 200, and 400 by 400. Specific geometries can be extracted from complex models as well. Maybe your company have a building model and for some reason needs to display only the walls. This could be done by extracting only the wall objects into a new .obj file that then can be further handled. Like maybe you want to view that on a viewer, all of that is possible. Metadata extraction. This is super helpful because information and properties of models are often more important than the model itself. And with the model derivative API, developers can access those data and use them on their operations. Maybe extract the list of properties for the parts of the models, something like that. I added here an image of the possible features and the workflow for the model derivative API. And this image actually illustrates really well what can be accomplished using this API. The Forge Viewer API, it's actually my personal favorite. With it, you can embed a viewer in your application and display 3D and 2D models to the user. The ability to see your models and interact with them in so many ways really brings the Forge experience to life. That's why this API is my favorite one. The viewer is web-based, which means that it's highly accessible. You just need an internet connection and a gadget capable of run WebGL, basically your PC or every phone available today. The viewer contains a lot of ready-to-use extensions, turning the viewer really beginner-friendly and improving the way that users interact with the model. Some examples of those extensions are the properties browser, the view navigation, and the ability to explode the model. And there are much more to try on the viewer documentation. And yeah, I spend a lot of time testing out the different extensions, the ready to use one, and even creating my own way of interacting with the model, which is the next topic. Not only the viewer contain extensions, it also contains a set of methods and classes to allow developers to create their own unique extension. So this allows companies to have exactly the workflow to suit their needs uh, to fit within their business model. Another thing, which is linked to the previous topic of having custom integrations, is that we can access the properties database to get information about the model. So maybe you need to serialize some information and display on a list. You can do that with the viewer API. And the last thing about this API is that it was developed using 3GS. So if your company have a very specific niche that is not possible to solve using the available viewer methods, your development team could enhance the viewer capabilities even more using the 3JS library. I have attached images here, one showing the viewer with the 3D model and the other one with the 2D model. And this is an example of how the viewer loads different types of model. And notice that the viewer detects the type of model and adapts the interactions and the available tools for each type.
All right, so let's talk about BIM 360 now. I'm sure that most of you already know what BIM 360 is, but for those who don't, BIM 360 is this suite of applications under Autodesk Cloud Solutions. It's like this huge cloud platform that contains document management, cost management, coordination, design collaboration, analytics, and so much more. Engineers, architects, designers, and even stakeholders use BIM 360 on their day-to-day lives to share design intent, to share models, to view metadata, to extract information, create requests for information, manage users, manage issues on the projects. So let's have a look on the docs part of BIM 360, which is a subset of the product as a whole. And this is the main user interface for it. All this is made on top of Forge. So if you see there, the folders are hosted on and retrieved from data management. The files in this case is one Revit project that you can see there on the bottom. It's already a converted file from the model derivative API. But, of course, all this is managed under the hood by the application, and the user won't see any of these complexity going on behind the scenes. If we open up that project in there, you can see that it will bring up the Forge viewer. This viewer is integrated with other functionalities on top of BIM 360, like issues, markups, and other things as well. So what you can actually do with BIM 360 APIs? Well, a ton of things. You can create and manage projects, add users, create and retrieve folders and files. The curious thing here is that you are going to use data management API for some of the files and the folder operations. Even if you have BIM 360, you have some merging between their two APIs. It's not surprising, right? Because they're all the same project under the hood. A very, very important feature is that it has the automatic conversion of files that you upload with no extra cost. If you're a developer and you're building something on top of Forge that targets BIM 360 users, you don't actually need to pay for the conversion of the file. BIM 360 does it already for you, no extra charges. On the flip side, unfortunately, not all the capabilities of BIM 360 are available in public for Forge. Support for RFIs, for instance, or access to user managements and things like that is still kind of limited. And as you can see there, some of the APIs are still in beta stage, so you can expect to have some limitations there as well. Let's see how these APIs are put in practice. I have a web form here from Shedmate, the startup that I work for. The form collects information about the project, normal things like client's name, email, addresses, and so on. And since this is a simple form, we can delegate anyone in the office to fill this up with the client, or even send that information so the client can fill that remotely, depending on the convenience on that specific case. The key here is none of these people, they know what BIM 360 is. They don't need to. They're just filling up a single form to tell where their shed will be located at. Here, you see the system collects information about the location of the project automatically. It uses Google Geolocation API. And also we have a simple form here to show that in a graphical manner too. And here's the job tab. This is specific information and internal to the office. The end clients don't actually need to see it, and assigning myself, I'm responsible for this specific one. I can later get information in emails and notifications and things like that. But the thing to note is that we have a job type here, which is something very, very important. Not only it will be sending along with the information to BIM 360, but it will also play another important part later on. So keep your eyes peeled for that. And now, if that projects go forward, the clients approve it, people that have BIM 360 access in the office or in the company will have the ability to synchronize this data from Shedmate to BIM 360. All that information that we collected there before with the client or with someone else in the office will play the important role that they are made for. We have the ability to create a project, send users, create folders, folder structures, and even send Revit files. Revit files, yes. I'll talk more about them later as we discuss this design automation for Revit. Look how a project ends up on BIM 360 on our system. Several folders are created. This is somewhat a complex folder structure that is specific for that job type. Remember the job type that I told you guys about? This is why. Depending on the project type, the user can select different folder structure and the files that will be automatically generated when the system creates the project on BIM 360. This is all done by a combination of data management APIs and BIM 360 APIs too. This is not just a huge time saver, but it's also something that gives us the peace of mind that we know that all these standards are now being followed and people won't make mistakes on creating all these files. Another great thing, of course, with BIM 360 is that these files are now accessible online. Even on the field, or mobile devices, where this information is most critical. And here's the list of all jobs created just for Blackbird Industries in the last year. Blackbird is a shed company from Australia. The screenshots are taken from inside of Revit because BIM 360 can actually synchronize Revit files directly instead of saving them to the user's local machine. Now, how many projects do you think Blackbird automated using this workflow? More than 300. Yes, more than 300 projects in just 2 years. Just a single shed company. Imagine how many hours of work they have saved. Imagine how tedious this process were before and how it is now. Now ask if they're gonna go back to the old system of desktop-based machines and processes. With all this, you would think that BIM 360 is my favorite APIs of all. But as much as I love it, there's something else that I love in Forge even more. Let's talk about design automation for Revit. So the design automation APIs are a set of Forge endpoints that allow you to access the engine of Autodesk core products via remote calls to their servers. It can be used to automate repetitive tasks, query the model, fetch metadata, ensure design standards, and so much more. The engines available at the moment are AutoCAD, 3D Studio Max, Inventor, and Revit. There are huge benefits here. You don't need to install anything on your user's machine, so the process can be all automated through the cloud, which makes things really easy for that user. You only need to pay by the hour, not by the instance of the software running, like a desktop app. So the process can be extremely scalable and can yield massive results and cost reductions. There are three main components to design automation: the app bundle, the activities, and the work items. The app bundle is a package with all your assembly files, your actual plugin executable files. Kind of like of the ones that you install on the user's machine, but this one is consumed by the cloud engine instead. An interesting trick here is to bundle any supporting files with it. Let's say that you reuse the same Revit template every time that you run design automation. It doesn't make sense to transfer all that template and that information over the wire each time. Instead, you bundle it up with your package, and then this template will be persisted locally and available for design automation each time it runs. A thing to note here is the process of downloading these files counts as a running process, so you pay for it. And you want to be as efficient as possible, and this little trick of pre-storing all these files will help a lot. Activities is kind of like the external commands in Revit. You executed it, run, and do some work, and then return. The difference here is that you have limited interaction with the network. So you need to collect all your users' input, send that information to design automation, and then wait for it to call you back with the results. So each activity defines what type of inputs, what type of outputs it will be supported. Also, it defines the app bundle that will be used. Work item is where you actually send the data to be processed to design automation. You specify the activity ID, so it will know what bundle to run and what type of inputs and outputs are to be used. So it's kind of like running the command on Revit user's interface. There are two ways of sending that data to design automation. If it is just a small JSON file, for instance, you can send that with the work item payload itself, or if it is a bit bigger, you can send it to somewhere else and then let design automation download that data in runtime. Data management API on Forge is the perfect fit here, but you can also use AWS or Azure, for instance. Design automation will run your code and then upload the output file. Here's the kicker though. This data is not kept after. Design automation will delete all the files used in the work item after the upload process is complete. So if you want to upload multiple files, you would zip them all, as you cannot go back to the work item once it's completed. So I have Revit open here with the resulting file. You can see that this is a native Revit element with all the elements created. So if I select a wall here, you see all the metadata is in there. Everything as we configured on the web configurator. If I hide the roof here, you can see that the frames are created too. The connections are there. The anchor bolts. Even the overlaps between the frames. All the doors and the framings, the headers, the floors. This one is a sloped one to the front. We have the footings in there as well. The columns. Even the skylights are there. If I go to the floor plan, you can explore here. Everything is dimensioned. This one is the arrow where this door will run. Some other doors in there. There's some detail lines. Information about the location of the spinaways on top, the bracings. We have excavation plans, for instance, all the elevations. Notice that the tags are there too. And if you go down, you see some schedules. Open the footing schedules, for instance. Cover page. So we have some sheets already created. Here are all the metadata that we configured on the web form there. So everything ties together in here. Floor plan is placed in scale, and the north position is already configured as well. Elevations to scale, sides, section views with the spacing for the frames on the roof and also in the wall. Even the concrete plans, the excavation plans, our structural cover. This will be sent to the engineer too. My roof framing in there with tagging for the elements. So yeah, everything is created in a matter of minutes. Okay, so how we managed to do all of that? What issues we found and how we solved them? Well, too many to explain on this presentation, of course, but let's focus on design automation here. The main thing to focus here is our software architecture. At the time, we chose to go with MVVM. MVVM stands for Model, View, View Model. And its job is to deal with the breaking up of your code on separate chunks. For instance, you need to separate your UI, your dialogues, your ribbon panels and buttons from your actual core logic of your application. That makes your code much more flexible, extensible, and modular. And I have to confess, we couldn't reach the perfect implementation of MVVM. Even always trying to improve with time, we always found ourselves breaking the rules here and there. And unfortunately, we have spent a ton of time to come up with logic to not to break the pattern. So that was a big drawback and a big issue that we faced. In the end of the day, it got the job done, but If I look back to the past now, I would go to a different pattern, something like MVC, for instance. But no matter what pattern you use, you absolutely need to have your WPF windows forms out of the main code of the application. Design automation cannot run UI there. So if all of a sudden your code opened a WPF window, for instance, design automation will just hang and not finish. So this is the results that you want to end up with. This is our solution on Visual Studio. Notice that we have all the different pieces of the application in different projects, so you can pick and choose the ones that you're gonna work with. You can see the name Shed Builder there. The product was actually rebranded now to ShedMate, but the project files still uses the old namespaces. Alphabetically, we have design automation logic itself. Then we have data models to host common use data across all projects. We have Revit app, which specifies the interaction with Revit database elements. UI app, which is something specific to Revit external application too. That's where your manifest file is and your external application is. Here we have the troublemaker view models to communicate with the windows and dialogues. Then we have our web application here as well to run the APIs on the back end. And then we have WPF windows and dialog here. So let's talk about the main pieces of this puzzle. Here we have the shedbuilder.revit.app assembly. It's the basic Revit app, and it communicates with the elements and the Revit databases. So here on the left, you can see that it references the Revit API.dll, and on the other side, it references our data models. Notice here that no UI interaction is created on this assembly itself. And this is important because this project will be referenced by the desktop app and the cloud application too. So next up, we have shedbuilder.revit.ui app. This is the main entry point of the application that runs on the desktop. Here we'll have references to dock panels and specific UI to Revit elements. Ribbons are created here too. So naturally, it needs to reference Revit API.dll, but also Revit API UI DLL. On the right, we can see that we have the references to our solution projects. You have the references to Revit app, the view models, WPF, and also the data models. And finally, we have our shedbuilder.revit.da assembly. This project is the one that will actually run and carry on with the tasks when a work item runs. Notice that it only references the Revit API.dll and not the Revit API UI DLL. And on the right, you can see that no references to UI elements are also present. So only the references to app and the data models. So let's go through the steps on how this DA project works. Unfortunately, I cannot show you any real line of code in this presentation, but we have here a pseudocode-ish to show how it works. Once the process is initialized and the files are downloaded, we deserialize the input JSON file into a data model. That lives on the models project that I showed before. Then it consumes part of that data to create the site plan for that shed. It carries on the dimensioning and notes and so on. Then it creates a 3D model of the shed itself. And after that, it creates the floor plans, elevations, sections, and then details everything up. Then it puts everything on the sheets that it needs to. For instance, bigger sheds will naturally need to have bigger scales or bigger sheets. Then it saves the files and use that as the outputs of the work item. That way, writing a new feature for our app immediately gives us the possibility of consuming that feature on a desktop or a cloud machine. So the important takeaway here is modularity. You don't want to write your code on design automation assembly itself. Instead, you will have its core logic business running in a separate assembly. All the functional calls that I showed you before on the slide were only calls to functions that live inside of the core Revit app. That way, when I write a new feature for my app, I immediately get that feature to be consumed on a desktop or a cloud environment. And in saying that, your code also now is testable, and you can run CI/CD pipelines on that, which are custom automations for deployment in your code. This also brings a huge benefit to the table and make your team much more productive and your apps more rock solid and powerful. And that's it. That's how we managed to get our Revit application, the desktop one, and to break it down and to port it to the cloud. As you saw, design automation doesn't really require too much code to be written by itself, but there's a lot of infrastructure around here. So it was a lot of work, but it's definitely worth it. All right, guys, that's what we have for today. If you liked the presentation or found it useful, please click the recommend button here on the page. Or if you have any questions, leave it in the comments. Raphael and I will be monitoring during the event.
Thanks everyone, it was a pleasure to have this conversation with you, and make sure to check the class materials for more information. There are some additional tips and tricks that we share there. Bye!
See ya!